there is no potential energy, delta K will be also different from 0. And this amount of kinetic energy change is what we will call thermal energy. So, when two cars collide and you touch the bumpers, how do you think that the bumpers will be? Half. That energy that is there is the amount of change in kinetic energy between the two cars. Before the collision and after the collision for the two cars. If you are able to find the change in kinetic energy, that change in kinetic energy will be the heat generated during the collision. On the other side, Pi will be equal to P final, but there is no change in mechanical energy. Ei will be also equal to E final. If it's along X, kinetic energy will be equal to kinetic energy final. This is basically the theory on collision. Then I will talk about momentum along X, in 2 dimensions, and the center of mass. With that will be the chapter. We will do problem now with this theory. What we have in the board basically is the theory that we will use. The sector elastic, I just will explain a little bit more in depth later. Let's start doing problems. Okay. Look, again, summarizing this, we have linear momentum, which is mass times velocity, is a vector. The impulse momentum theorem said that the impulse is the change in momentum, which is the integral of the force as a function of time, or mv final minus p initial, impulse momentum theorem. In addition to this, we get that Pi is equal to P final if there is no external force. How can we write this for two objects? This is one object, and this is a second object. We can say that if I have the mass and the velocity of this guy, and the mass of the velocity of the second guy, let's say that I have the mass of this and the mass of this, M1 and M2. I have B1 with the sensor, I can record B1, right? And or U1, we will label U before the collision, B after the collision. U before the collision, B after the collision. So U1 is given, the mass 1 is given, the mass 2 is given because they are similar mass. So if I ask what will be the velocity of the two objects after the collision, I can find what will be B for both cars because they are moving together. Or I can do the same, but here, and I can say, I give the velocity of this and the mass of this, and then I can say, find the velocity, assuming that doesn't touch, find the velocity of the two cars after the collision. Those will be the type of questions when we are dealing with the conservational law of conservation of linear momentum. How can we put it that for two objects? N1, U1, plus M2, U2, equal to M1, V1, plus M2, V2. This is for two objects. If we have N objects, will be N addition of momentum. This is the momentum of the first plus the momentum of the second plus the momentum of the third equal to the same thing. I will put point here and point here. Depends on how many masses we have. Very simple. Now, I ask in an inelastic collision for the heat generated during the collision, what will be 1/2 m1 v1 squared plus 1/2 m2 v2 squared. What is this? The kinetic energy initial or final for the system? Final. You can see final because it's V. But we want the change in kinetic energy of the system. What is missing here? Minus what? The kinetic energy of the first before. How can I label before the collision? 1/2 n1, and what will be? This will be the heat generated during the collision. Okay? So, let's say we have an example 1, for instance. Let's look at this is basically the first part of the theorem. Then we will combine. Let's start with question number, let's say for instance, number 2. How to approach. Question number 2. The only force acting on a 2 kilogram object moving along the x-axis is shown on the picture. The velocity Vx is negative 2 meters per second at t equals 0. So the velocity initial is negative 2 meters per second at t equals 0. The question is, what is the velocity at 4 seconds? Now we look at the concept. It's given a graph, velocity versus time. How can we find the impulse? If it's given from this definition, if it's given the graph velocity versus time, how can we get the impulse, or which we call changing momentum? Given the graph, area under the curve. Everybody can see that, because the definition of integral of the force with respect to the time. So the first thing is, if they are given the initial velocity, you are looking for the final velocity, you have the mass of the object. If we are able to find the impulse, which is the area under the curve, we can find delta P. Since we have the mass and V initial, we can find V final, right? So, in this case, the only force acting on a 2 kilogram object moving along the x-axis is given